In this video, we're going to look at the effect of concentration changes on chemical equilibrium systems following the idea of LeChatelier's principle. And the first thing that we're going to look at is what happens when we increase the concentration of our reactants. Well, according to the maxim, whatever we do, nature will attempt to undo. Because the stimulus is an increase in the concentration of reactants, nature, being the equilibrium, will want to take the concentration of our reactants and decrease them to bring the concentration back to the way that it was before. And we can do this by shifting the equilibrium in favor of the products. So by making more product molecules, it means that we are consuming more reactant molecules and causing the concentration to drop to the way it was before. Now, how do we explain this by looking at rates? Well, unlike with temperature, this is relatively easy to visualize because if we focus on one specific reactant, let's look at chlorine in this case. If we increase the concentration of chlorine gas, meaning that if we actually have a greater number of chlorine gas particles, that means that the number of collisions between reactant particles is going to increase as well. And if we have more collisions, that means that the rate of the forward reaction is going to increase with that, meaning that we are no longer at equilibrium because our forward reaction rate is now greater than our reverse reaction rate, which we can represent by having arrows of different length to show with a longer forward arrow that the forward rate is predominating. Now, as a result of this, our concentration of products is going to increase because our forward rate is greater than the reverse rate, meaning that our concentration of reactants is going to fall over time. However, as the concentration of reactants decreases gradually, our forward rate is going to slow down little by little, while increasing the amount of product molecules is going to increase the reverse rate, and again, we resume an equilibrium when these two rates become equal again. But because this change resulted in more products being produced, we say that the equilibrium shifts in favor of the products in order to balance this out. Now, if we look at concentration decreases, we can analyze them in the opposite way. So if we look at the maxim, whatever we do, nature will attempt to undo. If we decrease the concentration of reactants, nature, being the equilibrium, will want to take the concentration of reactants and increase them once again by shifting the equilibrium back to the reactants in order for us to make more. Now, how do we analyze this in terms of rates? Well, it's exactly the opposite situation as we've seen before. If we take the concentration of chlorine gas and decrease it by actually removing chlorine gas molecules from the reaction, now we have fewer reactant particles, which means the number of collisions is also going to decrease, meaning that the forward rate is going to slow down. And because we're in a situation where the forward reaction or forward reaction rate is slower than the reverse reaction rate, now we have the opposite situation where our products are going to have more collisions than our reactants are, resulting in more reactants being formed. And this is a situation that we call an equilibrium shift in favor of the reactants. Technically, we can analyze changes to the products in the same way, and again, this would basically be the mirror image of what we were to do with the reactants. For example, if we were to increase the concentration of this molecule here, that would mean that the number of collisions between product molecules is going to increase, and since we haven't modified the reactants in any way, we have a situation where our reverse reaction rate increases because of the greater number of collisions, and now the reverse reaction rate is greater than the forward reaction rate, and therefore our equilibrium shifts in favor of the reactants. And this makes perfect sense because whatever we do, which is increasing products, nature will attempt to undo by shifting the equilibrium away, producing more reactants, and therefore consuming more products in order to decrease the amount of products that we have. Conversely, if we do the reverse, if we take the product molecule here, and if we decrease the concentration by removing product molecules, that means that we are going to have fewer collisions between our product molecules, and therefore the reverse rate is going to decrease as well. And now we have a situation where the forward rate is now faster than the reverse rate, which means we are going to get more products forming in order to counterbalance the original stimulus that we added. So if we put these into succinct concluding statements, if the concentration of products increases, nature, being the equilibrium, will try to counteract this by shifting the equilibrium to the reactants, and when this happens, that will cause the concentration of our product molecules to decrease, thereby reversing the change. Conversely, if the concentration of products decreases, the equilibrium is going to shift back to the products in order for us to make more, which again, because we're shifting back to the products, that means that the concentration of product molecules is going to increase. In the next video, we're going to look in more detail at the same type of situation involving concentration changes, only the concentration changes we'll be looking at in the next video will be specifically related to gases and specifically related to pressure changes that cause concentration changes and the effect that those have on a dynamic equilibrium system.